In this video, we're going to be looking at classifying data as direct variation, inverse variation, or neither. So if we have a data set, we can tell what type of variation it has by looking at those data pairs. So for direct variation, we see that our equation, which we recognize would be direct variation, y equals a over x, can be rewritten as y over x is equal to a. And so we see that a set of data pairs xy shows direct variation when the ratios y divided by x are constant. So we can tell if we take all the data pairs and we take all the y's and divide it by the x, the corresponding x that goes with them, and if that comes with the same number, then that means that that's going to be direct variation. For inverse variation, we know that that equation is set up as y equals a over x. So if we solve that for a, we see that that can be written as x times y is equal to a. And so if when we have a set of data pairs, we can see that it shows inverse variation when the product x times y are constant. So if you take your data pairs and you multiply those numbers, and if they end up being the same number, that means it's going to be inverse variation. So let's look at some examples of classifying the data. So for this first one, we have the data pairs 2, -12, 4, -6, 6, -4, 8, -3. So I want to go ahead and first check to see if it is direct variation. So I want to do y divided by x. So when I do that, I'm taking all my y values and I'm dividing it by its corresponding x value. So if I look at that first one, I have -12 divided by its x pair, which is 2, and I get -6. The next one is -6 divided by 4, which if I simplify that, that gets me -3/2. Automatically, I see that this is not constant. I got a different number for my next point. So I automatically can tell, okay, this is not direct variation. Now let's see if it's inverse variation. So for inverse variation, the products need to be constant. So now instead of dividing them, I'm going to be multiplying them. So I have 2 times -12, and I get -24. 4 times -6 also gets me -24, so we're off to a good start. 6 times -4 gets me -24. And 8 times -3 also gets me -24. So I see when I multiplied, I got a constant number of -24. So since the products were constant, that means that this shows inverse variation. Remember, for direct variation, we're looking for y over x to be constant. Inverse, we're looking for x times y to be constant. Okay, let's look at this next one. So first I'm going to try the y over x to see if it is direct variation. So for that first pair, I have 2 over 1, which equals 2. My next data pair, I have 4 divided by 2, which also gets me 2, so I'm off to a good start. My next one, I have 8 over 3, which gets me, I can't simplify that, so it's just 8/3. So here I see I started off with the same number, but my third point, I ended up with 8/3, so this is not constant. So this is not direct variation. Okay, let's check for inverse variation. So I'm looking for x times y to be the same. That first point, I have 1 times 2, which gets me 2. The next point, I have 2 times 4, which gives me 8. So I don't have a constant number here. I have 2 and then I have 8, so this isn't constant. So both of these were not constant. So that means that this one is neither. It's not direct variation and it's not inverse variation. Okay, let's look at one last one. So I'm going to first check to see if it's direct variation. So I'm going to do y divided by x, not x over y. So my first one, I have 20 divided by -4, and I get -5. Next point, I have 15 divided by -3, and I also get -5. Next one is 10 divided by -2, and I see I get -5. And then 5 divided by -1, and I also get -5. So I see I got the same number each time, so this is constant. And so since y divided by x was constant, that means that this is direct variation.